geometry. And red doesn't usually show up as red. So 3 things I have to show you. We're going to go back and do section 5.3. And that was about, which I'm pretty sure that a lot of you know about scientific notation already. Scientific notation is just a shorthand way to write numbers. You know, back in the old days, they didn't have calculators. And so, like for instance, oops, I think I screwed it up. 1, 2, 3, 4, 5, 6, 7, 8. That number right there, that's the speed of light. 300 million meters per second is the speed of light. Or if I wanted you to write the mass of an electron, 11, 12, 13, 14. And back before they had calculators, what if I had to multiply these 2 numbers together? Or divide? Or even doing adding and subtracting? When you have that many zeros, that much, they had to come up with a way to make it simpler to write things like this. And that's what scientific notation is. Scientific notation is just a sort of mathematical shorthand. You know, I don't know if anybody writes shorthand these days anymore, but there's called shorthand in the business department, and it's a way to write things really quick, if you have to go quick, and short, rather than writing out full words and full sentences. Well, that's what scientific notation is. It's a mathematical shorthand that it doesn't write all these zeros in here. It doesn't write all these zeros. Does anybody know how to do scientific notation already? A few of you. So what scientific notation does is it basically gets rid of all those zeros. You know, would you agree that we assume there's a decimal right here at the end? We just don't write it. Well, scientific notation, you take that decimal and you move it all the way so that you have 1 digit to the left of the decimal. And in this case, there isn't going to be anything else, but we move the decimal so it's 1 digit, and then it's times 10 to, it's always times 10 to some power. And the way that you figure out the power is, how many places did I have to move that decimal? 1, 2, 3, 4, 5, 6, 7, 8 places. So I would write it as 3 times 10 to the 8th. If I had something like 5, 7, 6, 0, 0, 0, 0, 0, well, I assume there's a decimal right here, and I'm going to move it so that I only have 1 place to the left of the decimal. So that would be 5.76 times 10 to, how many places did I move the decimal? 1, 2, 3, 4, 5, 6, 7. Times 10 to the 7. Does that make sense? And if, for instance, it's a really small, if you're moving the decimal the opposite direction, we're going to move it all the way right there so that you have one digit to the left of the decimal. So 9.71 times 10 to the, and since we're moving it the other direction, it's going to be a negative exponent. That's the only difference when you go the opposite way. Who's going to count up all those places? 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm losing my breath. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. That's what I thought. 10 to the negative 31 kilograms. I think I should get a bonus today for writing all those. Does that make sense? I don't think I need to spend a whole lot of time on that, right? Yeah, just need to remember one digit to the left of the decimal. Even if there's more than one digit, you only need one decimal place, or one whole number, I should say. One whole digit. Same thing here. You only want one to the left of the decimal, and then everything else goes to the right. Make sense? Say that again. If you make it instead of, yeah, you're right. You are right about that. But does this make sense? So I didn't use a whole day for this because it goes kind of fast. You can get that. Anybody with questions on the scientific notation part? Then I also have a little bit more from from section 5.4. We didn't quite finish it. We did the factoring and canceling part, but find the domain and find the zeros. Find the domain and find the zeros of, let's pick a function, f of x equals, how about this one? 2x squared minus 7x plus 3 over x to the third plus x squared. No, I think I screwed that up. I did plus x squared minus 2x. Let's use that same function over here for the domain. So I have a function, and I'm supposed to find the domain of the function and find the zeros of the function. Let's start with find the zeros of this function. Well, if we're going to find the zeros, we need to know what does that mean to find the zeros of the function. What does that mean to find the zeros of the function?
What could I do that would be 0?
Exactly. She said the zeros of the function are, what could x be that would make this whole thing equal 0? What values of x would make that whole thing equal 0? Do you know when that whole thing would equal 0? That whole thing would equal 0 when, say that again? Close. It is the top. Yes. And I think we've sort of done this before. That whole function will equal 0 when the numerator equals 0. That whole thing, we don't care what's in the bottom, because remember, 0 over anything is 0. 0 over 100 is 0. We don't care what's in the bottom. We just want to know what's in the top. This whole function is 0 when the top is equal to 0. So you are going to set the numerator equal to 0 and solve it. I think you should know how to solve it. I'll remind you, but I bet you know how to solve it if you think. I'll give you a hint. Yes, factor it. Factor it. Oh, I know, and those freshmen that are learning factoring, they don't believe me when I tell them, you need to know how to factor. What did we do yesterday? Oh yeah, yesterday we factored and canceled. Today we're gonna factor and solve. And if you can't factor, you're gonna be in a little bit of trouble. Does this thing, doesn't that have to be 2x and x? Down here for 3, I only have one possibility to get a 3. It's got to be 3 and 1, but you got to get them situated correctly so that you get a 7 in the middle. What should go here?
1.
Right, 1 and 3. Signs,
Minus.
it's a positive here, so they either have to be both positive or both negative. Right, both negative. And then I make them do the inside-outside double check still. What's this? Negative 1x. And what's this? So that if you got it right, this should add up to this. Well, once you have it factored, we'll go over here. Once I have it factored, 2x take away 1, and an x take away 3, and that equals 0. Remember? Well, if you're multiplying two things together and you get an answer of 0, what does that tell you about one of those two things? One of them has to equal 0. So either 2x minus 1 equals 0, or the other one. Okay. So add 3, and one possibility is x equals 3. That's one of the zeros. If you plug 3 in there, this whole thing will equal 0. The other value here, add 1, divide by 2, and you get x equals 1/2. That's the other 0. I think we did this before. So, anybody with questions on this one? Really, it's just set the numerator equal to 0, and then factor it and solve. But we also have the other half. Find the domain. Find the domain. How about if we find Mrs. May? There we go. Find the domain. Well, do you remember? In a fraction, what can't you have in a fraction? You can't have the denominator equal to 0, right, John? You cannot have the denominator equal to 0. So this thing right here, the x cubed plus x squared minus 2x, that thing cannot equal 0. The denominator of a fraction cannot equal 0. The denominator is not allowed to be 0. We don't know what that is.
Okay,
What?
so how come here
The numerator can be 0 because what is,
well, we just get the denominator.
we did the numerator over here. For the zeros, it's the numerator. For the zeros of the function, we want to know something about the numerator. For the domain of the function, we want to know about the denominator. The denominator cannot be 0. Over there it can. Numerator can be 0, but the denominator can't. And By the way, before I go any farther, do you remember this? The domain equals all real numbers except, remember that? We could put any real number we wanted into here for x, except we can't put any number in that's going to make the denominator equal to 0. So for this one, we have to set the denominator equal to 0. And then we have to do just like we did over there. We have to factor it and solve it. So for this one, do you notice there's an x in common for all of those? So we take the x out, and then this x squared, that has to be x and x, and a 2, that has to be 2 and 1. What about the signs? Like that? Yeah, because then it's plus 2x. And then if I go this way, minus 1x. And if you combine those, it better equal what you have in the middle. So there's my factored equation. I'm going to move it over here so I can work with it. I have x plus 2, x minus 1, and equals 0. So either this thing, or this one, or this one. Either x equals 0, like that. Well, this one I'm already done. I got x equals 0. Hey, these aren't too bad. Minus 2 minus 2. Add 1, add 1. Hey, these aren't so bad at all. So I got all real numbers except these three, except 0, -2, and 1. This right here is my domain. All real numbers except 0, -2, and 1. And why is that? Because all of these values make it equal 0. All of those values make this denominator right here equal 0. And that's not allowed. That's not allowed. So what? It's not allowed. Right. It's not allowed. The denominator can't equal 0. That's not allowed. Does that make sense? So 3, this one's kind of separate. I'm going to give you a few problems of scientific notation. And then the other, you're going to have a fraction, and it'll be part A, part B. I think it's part A, you set the denominator equal to 0. And that's what you have to throw out. You're not allowed to have those values in your domain. For part B, you're looking for the zeros of the function. That means you're looking for where is the numerator equal to 0. So those are the values you actually want. These are my answers then. Does that make sense?
Yeah.
Does that make sense?
Yeah.
Do you have questions? Are there any questions? Does anyone have a question? So I got 2 pages. We're going to go page 223. And on 223, 1 through 12, there's not really any work to show. Page 223, 1 through 12 is just looking at it like this and writing it in scientific notation. Then the other one, let me just double check. It is page 229. And I have I think 21, 22, 25, 26. 21, 22, page 229. 21, 22, what did I say, 25 and 26, I think. Yes, 25, 26. That shouldn't take you too long, I don't think. And 2 weeks from today, the test, so you could always start going back to look at old sections, problems that we did. You can even now go back in Google Classroom. If you forgot how to do something, go back in Google Classroom and